So coding things in digital form also allowed engineers to look at a different type of multiple access technology. And this will be the second type that we look at. So the idea is as follows. Let's consider our standard time frequency division. And we saw before with FDMA that every transmitter would get a different frequency band. So person A is on this frequency, B is on this frequency, C is on this, and D is on this one. And that's how they're distinguished over the same network medium. That's how they share the air, if you will. So let's try to think of a way we could fit more people into this diagram. So what about having every frequency carry multiple users? So something like this. First off, at the first time, A1, B1, C1, and D1 are transmitting. Then at the second time, A2, B2, C2, and D2 are transmitting. Then A3, B3, C3, and D3, and so on. And so we're adding a time division on top of this frequency division, so that on every frequency, we've now put 3 different people in here. It goes back to our time sharing that we talked about in our initial analogy. Basically, these 3 users can take turns on this one frequency. And then they can repeat again. So then A1 would have its turn next, A2, and A3, and so on for each frequency. So you see we have 3 different things going on here. Not only are people now on different frequencies, but now we can fit multiple people on the same frequency as long as we divide them in time. So you're probably asking, well, that's great, and now we have a 3-fold improvement in capacity because now we can have 12 people. These are just 12 blocks in here, rather than just 4 people. Why didn't we do that before with FDMA? Well, with analog signals, it's not possible to compress multiple signals onto the same frequency band. So we can't do this. We can't do this time sharing. Analog just doesn't allow us to do that. But digital technology allows us to do that compression so that we can take these 3 signals and put them on the same frequency band and still have the receiver distinguish between them. So one of the advantages of digital coding was to allow us to move to this next multiple access technology. So this is called TDMA, multiple access, as we know again, but rather than frequency division, we now have time division on top of that. So this is time division, multiple access. So you're probably wondering, well, it really still is kind of frequency division because we do have different frequency bands. What we're really referring to here with TDMA is that on top of FDMA, we're now allowing multiple people to share the same frequency band. So it has a TDMA in it as well. But in the strict sense, a TDMA system would be a single frequency having multiple users. But it doesn't make sense to do that because we know that we can have multiple frequencies. So when we say TDMA, we're really referring to a chart like this rather than just a chart of a single frequency with multiple times. So as we said, we could not do this with analog. This was only made possible once digital technology was allowed. So the first technology to employ TDMA was called GSM, or Global System for Mobile Communication. And that came out in 1982. GSM was quickly shown by 1987 to have a 3 times improvement over the previous analog capacity with the AMPS network. And that 3 times improvement in capacity comes about because now we can have multiple users sharing the same frequency band. Now, GSM was adopted in Europe rather quickly because the European Union favored a single standard because they wanted to have what's called interoperability. Interoperability. And so they didn't want to have multiple standards because they wanted to support things like roaming from one area to another. So they wanted each of their cell systems to be using these same standards. They decided that let's adopt GSM because it looked good at that time. And they said, let's adopt it so then everyone will be using it. And that's exactly what happened. So they had a mobile standard